We find distance between two numbers using subtraction. So between 3 and -2, we just subtract them. 3 minus -2 is 3 plus 2, and 3 plus 2 is 5. What about between -2 and 3? Subtract them. -2 minus 3 is -2 minus 3, which is -5. And that's an issue. So we're going to rectify this issue where we have -5 and 5, doing it different ways of how we're looking at it. It should be the same thing, but we're going to rectify this by using the absolute value. The absolute value of a number, x, is its distance from 0. That's the key thing to note here. And it's designated using these vertical bars around it. So if a number is the only thing inside the bars, the absolute value is very simple to calculate. You just make the number positive. So the absolute value of -2, -2 is 2 units. If you look at a real number line, it's 2 units away from 0. Therefore, the absolute value of -2 is 2. Likewise, the absolute value of 3 is 3, since it's 3 units away from 0. Now, if we do the subtraction with the absolute values around it, we have 3 minus a -2 becomes the absolute value of 3 plus 2, absolute value of 5, and the absolute value of 5 is 5 units away from 0, so we get 5. -2 minus 3 is the absolute value of -5. -5 is 5 units away from 0, so we get 5. And here we get the same answer, which is what you always want. It's also important to note that distance, which is what an absolute value is always positive or 0. So in this previous one here, we found a distance of -5, and that is directly contradicting the definition of what distance is. So that's another reason why we need to use the absolute value. Absolute value is just a grouping symbol in order of operations, as well as additional meaning behind it. So make sure you're doing it with the grouping symbols. So in this problem, we have absolute value and this fraction bar. So we have 2 grouping symbols. We need to do the numerator and the denominator, and then all that stuff before we do anything with the 1.3 and -5.6. So I'm going to work on first this multiplication and this multiplication. Doing that is going to give us 37.35 minus 12 plus 4.2 over 5. Okay, now I can do this entire numerator. It's important to note here what I'm doing is I'm solving this expression because I don't have any variables in it, so there's no like terms I need to worry about. All I'm working to do is simplify it down to a single answer. Okay, adding and subtracting everything in that numerator, that's going to give me 29.55 over 5. Okay, now I can do that division. 29.55 over 5 is 5.91. Okay, the absolute value of 5.91 is 5.91. It's 5.91 units away from 0. So we're going to get 1.3 times 5.91. And now we can just do order of operations here. 1.3 times 5.191 and then subtract 5.6 from that. So doing that, that's going to give us 2.083. Okay, for this next problem, we have variables, but we know what the variables are. So we can just plug them in and simplify the expression, or solve the expression, I should say. So we have -5.6 times k, which is 4, and L, which is 13. Here I don't need the parentheses because it doesn't really clarify anything. It's just kind of actually clutters things up. So I'm just going to drop the parentheses there. Now you can see I can do 856 times 4. That's negative 224 plus 13. So negative 211. And the absolute value of negative 211 is 211. Okay. For this problem, we know what S and T are, so let's go ahead and plug them in. We have 2 times S plus T cubed over T plus 9, the absolute value of all that, S over 32 minus S cubed. And kind of doing this whole thing, there's fractions and there's absolute value, so lots of these things are being separated. I can do a lot of it at the same time. I'm going to do this on the numerator there, and this all at the same time, because I have to do those in each one of these parts to continue forward. So let's go ahead and solve that. We're going to get 2 times 3 plus a negative is minus, so 3 minus 4 is negative 1 cubed. Negative 4 plus 9 is 5. 3 over 32 minus 3 cubed is 27. Okay, now I can do this portion here. The 5 is all good, the 3 is all good, and I can do this portion here. It's going to give me negative 1 times negative 1 times negative 1 is negative 1. And here we have 32 minus 27 is 5. Okay, now I can do this portion here. That's going to be negative 2 over 5 minus 3 over 5. At this point, you can translate these into decimals. This first one's going to be negative 0.4. This one's going to be 0.6, but we commonly leave fractions inside answers. So I'm just going to leave it as fraction and just think of the fraction as a number. It's negative 2 over 5. The absolute value of negative 2 over 5. It's 2 over 5 units away from 0, so it's just going to be 2 over 5. And the absolute value of 3 over 5 is just 3 over 5. These have common denominators, so we can subtract the numerators. 2 minus 3 is negative 1 over 5. And this is the key thing I wanted to show here, is that our answer was negative. Even though I said absolute values is always 0 or positive, that's because of this middle negative sign here. That's what made it negative. If you had absolute values around the entire problem, then you'd always have a 0 or a positive answer. But in this case, if you have this negative here, the interaction can make it negative. So don't fall for the trap that thinking it's always going to be a positive or a 0 answer. That's not the case. It all depends on how the different terms inside the expression interact. Okay, give this a try in number 3 and 4. An equation is a statement saying two expressions are equal. That's an important thing to note, is that an equation is just two expressions on either side of the equal sign. And these represent truth statements. So we can either test the statement to be true by finding the values or choosing values, or we can find when it's true, or we're just making a statement that this thing is true. There's a lot of things you can do with equations, but they're all based around, is this thing true, or you're stating that this is a true relationship. Now, they can be statements of fact, as I said here. We can have it as a question. So when is x plus 1 equal to 4 true if x is a real number? Well, this is saying the same thing as just saying x plus 1 equals 4. If I gave you x plus 1 equals 4, that's the same thing as saying when is x plus 1 equal to 4 true. That, of course, is true when x equals 3. 3 plus 1 equals 4. Okay, for this next one, 3w plus 5w minus 2 equals w plus 7w plus 1. Well, here I have like terms. We're just looking at this thing and this thing separately. These are just expressions. And inside each one, we have like terms. 3w plus 5w is 8w. And w plus 7w is 8w. And then plus 1. And it's asking, when is some number multiplied by 8 minus 2 equal to the same number multiplied by 8 plus 1? Here we're subtracting 2, here we're adding 1. This is never true. So inherently, this you can test this out. Just go ahead and test a bunch of numbers out, and you'll see it's never going to be true. This statement is never true. In other words, this is what we call a contradiction. Those two things cannot be equal. Okay, give it a try in number 5. If I ask the question, when is the equation x squared equal to negative 1? Well, this will give you no answer when you're working with the real numbers. However, if we expand our number system into the complex numbers, then we do get an answer. In fact, there's two answers, I and negative I. And we're going to talk about these things a little bit later on. But sometimes if you expand what you're thinking about, expand the universe set, for instance, you can actually find solutions. But if you're restricted to a certain universe set, like you cannot expand it, then this, for instance, for the real numbers, this equation is never true.